Hello everyone, I'm Mia. Today I have a question that I'll share with you all. The question is, a 10.0 kilogram mass is resting on a horizontal surface. A force of 100 Newton acts at an angle of 30.0 degrees to the horizontal. A. Calculate the normal force. B. Calculate the magnitude of the force of friction. And C. What is the acceleration of the mass? We begin by drawing a free body diagram. We have a 10.0 kilogram mass resting on a horizontal surface. Because the object has mass, there is a force of gravity acting on the mass, which is the force of the Earth on the mass. Since the mass is in contact with the surface, there is also a normal force, which is the force of the surface on the mass. In addition, we have a force of 100 Newton at an angle of 30.0 degrees to the horizontal. We draw a right triangle. By using trigonometry, the vertical component of the force is 100 Newton times sine 30 degrees, and the horizontal component of the force is 100 Newton times cosine 30 degrees. We also have a force of friction acting in the opposite direction of motion. Before jumping into the calculations, I divide up and right at positive directions. Part A. Calculate the normal force. We use Newton's second law in the y directions. We have Fy equals ma. In the y direction, we have three forces: normal force upward, vertical component of the force upward, and force of gravity downward. Because the mass does not accelerate vertically, the acceleration in the y directions is 0. Therefore, we have normal force plus 100 Newton times sine 30 degrees minus force of gravity equals 0. Normal force equals negative 100 times sine 30 degrees plus 10.0 times 9.8 equals 48 Newton. So the normal force is 48 Newton. Part B. Calculate the magnitude of the force of friction. The formula for friction is force of friction equals mu times normal force. We are given the coefficient of friction, which is 0.620, and normal force, which is 48 Newton. Therefore, force of friction equals 0.620 times 48 equals 29.76 Newton. So the magnitude of the force of friction is 29.76 Newton. Then we move on to part C. What is the acceleration of the mass? We again apply Newton's second law for the x direction. We have Fx equals ma. In the x direction, we have two forces: force of friction to the left and horizontal component of the force to the right. Because I define right as the positive directions, we have 100 Newton times cosine 30 degrees minus force of friction equals ma. And we already know force of friction and mass, so we have 100 times cosine 30 degrees minus 29.76 equals 10.0 times acceleration. After calculating, the acceleration of the mass is 5.68 meters per second square. Thank you for listening.